in this conference and uh, watching and listening my presentation. My presentation is today based on our paper, which is based on climate change and social change, the role of climate tech and non-climate tech in idiosyncratic risk and global financial stability. So we in this paper we have three main authors: Sajid from Aston Business School, myself Rizwan Ahmed from Birmingham University, and we have Shamai Pon from Konkan University, Thailand. So this paper is still in the working stage. So I'm just trying to give you an idea about how we are developing this paper and what are the main aims and contribution of this paper in order to work on the climate change based on technology companies. So the introduction, in our introduction, as we all are aware about this, that recently we have a COP26, the climate change conference in Glasgow. The world is ever more aware about the issue that arise from the climate change, and this is one of the biggest threat nowadays for the whole world. And we also understand that not only the individuals but also large corporations are responsible for some of the humanity's most significant environmental impacts. Since large corporations have a large amount of money, they can potentially contribute significantly to the carbon reduction of the carbon emission. So the motivation is coming from the area that we have a lot of conferences based on the climate change, awareness about the climate change, and the threats of the climate change. So we integrate that kind of a thing into the particular companies, which are the tech based companies, which are one of the richest companies in the world in the US market as well. So we are looking for that how they are coping up with the climate change. We adopted the EVT, the extreme value theory, in this methodology, but we are looking for the tail risk awareness that will appear in terms of the risk factors, and we find out that the tail risk awareness came first through the financial crisis, which we have seen in 2007, 8, and 9. So we try to apply the same concept of tail risk into our climate change risk as well. This brings us to the question that whether the corporations that are environmentally friendly are compensated with low risk premium compared to the ones that are not. The intuition is that the tech corporations that are environmentally friendly and less vulnerable to the company's specific events that adversely influence the financial markets. So we try our analysis based on that the tech corporations are environmentally friendly or not. If they are not, why they are not doing this thing, or they are not aware about this. Presently, there exists considerable research on the relationship between the tech corporations and the non-tech corporations. However, these studies have left the analysis of the relationship between the downside trail risk and the climate risk of the tech firms. So the literature is more or less, we have seen about the climate risk in our literature review, and mostly the literature review is moving around the cultural, environmental issues, global economic risk factors, which has been researched thoroughly by many scholars such as Havitt 1983, Kelly and Edgar 2000, Lichinko and O'Brien 2002, and Wisner 1977. There's a still gap exist where the richest companies in the world, how they are behaving with the climate risk. That is a core aim and contribution towards our research paper as well. The threat of the climate change has brought climatic vulnerability to the center of debates over sustainable development, such as Gates 2000, and organizations such as the World Bank also places a risk management as a core concern of social policy. According to the Holzman and Jorgensen's 2000, the World Bank report also appeared in 2000 as well about this. The O'Brien and Lenchenko explained that how global political economic situations changes with the climate risk to affect the livelihoods and development opportunities of a particular population. Condi, Ferrer, and Lieberman 2000 also expressed their concerns about the max rising of the temperature, and this could translate into a warmer temperature could translate into a reduced risk of forest and thus improve yields. Although such a result would depend on the increase in atmospheric moisture as well. So changes in the atmosphere and the climate also impact different businesses in a different way. What we adopted or we are trying to adopt our methodology and data. Our full sample of climate tech firms is from 1st January 1991 to 30th June 2021. We have distributed the data into different formats. We also collected the Bitcoin data, which is only available from 2013 October. So do we have a three sets of results for climate tech firms, which are full sample is from 1st January 1991 to 30th June 2021. Same sample for the Bitcoin we have taken from 1st October 2013 to 30th June 2021. And we also define the pre-COVID environment and the post-COVID environment. So we have a pre-COVID sample, which is existing from exactly matching with the Bitcoin 1st October 2013 to 31st December 2019. For Bitcoins, we have only, in other words, the Bitcoins, we have only for two results, which is starting Bitcoin 1st October 2013 to 30th June 2021. There's a full set of the Bitcoin. Another one is a pre-COVID sample, which is 1st October 2013 to 31st December 2019. This is the pre-COVID scenario. Post-COVID scenario, we are not doing because we are still in the same position. We are not that much aware about that we are fully recovered from the COVID scenario. So we are concentrating only on the pre-COVID scenarios. So data and research methodology, what methodology we have used, as I mentioned, we are using the univariate extreme value theory, EVT. EVT is already used in before as well. So we apply this EVT methodology into finding out the tail risk in our analysis. Actually, EVT is to measure the equity tail risk. The univariate EVT comprises of generalized extreme value theory distribution, and that is the limit law for maxima of the stationary process. Value at risk is an important risk measure for risk managers, regulators, and investors, even though it is not coherent risk measures. Therefore, we also use expected shortfall, which is a conditional expected loss given a sharp fall in the equity capital. The expected shortfall shows how bad things can go once loss exceeded to the war boundary. So we applied actually the extreme value theory in our main core aim, and about the main findings which we have got as a preliminary findings, which just I want to share with you. We found that the climate tech firms on average are less riskier than Bitcoins. Bitcoins are more volatile and they behave more when we are talking about the climate aspects. On average, climate tech firms show more systematic risk compared to Bitcoin. This can be explained by the fact that the Bitcoin might be working as a safe haven, similar to gold. One interpretation is that investors hedge their risk by investing in the Bitcoin if there's a systematic shock in the market. So this is the brief overview of about our work we have done so far, and we have some results which is still a preliminary results which we don't want to show you at this moment, but I'm open if anybody has any questions regarding our presentation so that we can discuss about this. Thank you very much.
Everybody, my name is Maria Chiara De Enrico. I'm an economist and a researcher at the Department of Economics of University of Perugia. And today I'm going to present a study I wrote with Professor Paolo Pulinori and Simona Viterna of the University of Perugia. The paper is titled Climate Change at Local Level, which commitment cities undertake to address action of adaptation. The study was born from the evidence that cities has become the core pillar of climate change mitigation actions, and since the Paris Agreement in 2015, the number of cities undertaking climate mitigation programs has more than doubled, but these urban policies need to be tailored according to the specific characteristics of the cities. Therefore, the objective of this study is to evaluate the urban mitigation program that cities have undertaken in 2020 worldwide, accounting for the program specific, the urban specific, and the structure of the emission, black carbon emission. What is here the empirical strategy I'm going to show you, and how to evaluate the climate tech solution voluntary undertaken by cities. We use determinant analysis, a multivariate regression model, and the dependent variables of this analysis are the expected targets that each mitigation program set at urban level, that are the renewable production, the black carbon emission reduction, and the energy savings. Now, let's have a deeper look to the data we are going to use. We use data from the ICLEI reporting system database, where more than 700 of cities disclose information on their climate mitigation programs they have undertaken in 2020. These climate mitigation programs essentially cover all the almost the main greenhouse gas emitting sectors, and the programs cover most of the climate change mitigation action, that is decarbonization, renewable production, and sustainability. But the most interesting data the reporting system discloses concern the expected climate outcomes in terms of emission reduction, energy saving, and renewable production. We use this data as dependent variables, but we use the intensity variables. That means we are going to divide this quantity by the urban gross domestic product in order to avoid that this kind of variables can be dependent on the business cycle fluctuations. Now, can we go straight forward to see instead the determinant, the program specific and the city specific factors that are used as determinant of the analysis. And for what concerns the program specific factor, we use a variable representing the number of means of implementation used in the mitigation programs at urban level, and then the dummy variable identifying the programs where programs with synergies, with spillover in other sectors that can be the economic growth, the job employment, or the public health. Then let's have a look to the city-specific factor that, following up consolidating literature, we use the urban population densities and artificial land cover rate that want to proxy the urban sprawl, and that is the ratio between the urban sprawl rate and the ratio between the built-up area and the total urban area. Then the last and most important variable is the a variable that want to divide the cities according to their emission structure, take into account the sector where black carbon emissions come from. And we, to construct this determinant, we use cluster analysis that consider as variables the emission share at urban level from the main gas emitting sectors, that is residential, transport, energy, industry, and agriculture. And we two different cluster variables. The first has dependent variable. Take into account the emission share from the transport and residential sectors. The second, the emission share from the industry and energy sector. And the next two slides want to depict how cities in this sample are divided according to 4 different groups. And here you can see in the first cluster that the cluster 1 represents cities with where the main sources of emission share is the residential sector. The cluster 4, the yellow points, represent cities where that have balanced emissions between transport and residential sectors, while cluster 3, the green points, represent instead define the cities where the main sources of emissions is the transport sectors. The next analysis, cluster analysis, is depicted in the second scatter plot, and you see that the first group of cities, cluster 1, concern cities where the main sources of emission is the industrial sector, while cluster 4, you see cities where the main sources of emission is the energy sector. We can say these cities are energy sector oriented. And in this table, I just want to show you the main summary statistics for the determinant used in the multivariate analysis. And here, the next slide wants to show you instead the econometric model used in the determinant analysis. We use a multivariate regression model where the dependent variables are the climate outcomes expressed in terms of intensities, the emission reduction, the black carbon emission reduction, energy saving, and renewable production. And these 3 variables are linear function of program-specific, city-specific factors and the structure of emission. And go straight forward to the table that wants to depict the main result of our analysis. Here in the first block, we show you the coefficient estimates for the first equation of the multivariate model, the equation that uses as dependent variable the emissions intensities. First of all, we see that the dummy defining programs with the spillover, or we can say with spillover in other sectors, positive affects the levels of the expected outcomes in terms of emissions. Looking instead to the city factor, city-specific factor, first we see that density is, when significant, is positively related to the expected climate target. And these findings you will find in all the other equations that uses energy saving intensity and renewable production as dependent variable. And this finding is consistent with the findings of many scholars that they say that when cities with higher density, higher urban density, reduce the use of vehicle, the ownership of vehicle, as well the per capita miles, and therefore the density is a factor that is positively correlated with the reduction of black carbon emission in the cities at urban level, we can say. Then look at the sprawl rate index. This is negative related to the emission reduction. That means that the more the cities are compact, and the higher is the climate target they try to set in terms of emissions reductions. Looking instead at the first variable of the first cluster, where the emissions, where the variable are the share of emissions in the transport and residential sector, you see that only the group 4 cities with a balanced emission between transport and residential sector is significant and positive related to the emission reduction targets, while looking at the second cluster variable, cluster 2, you see that the cities, if belong to the second groups, that are, if I remember, the industry-oriented cities, tend to set a higher level of targets in terms of emission reductions. Looking instead to the second two block of the table concerning the energy saving determinant variable and the renewable production, the sign of coefficient estimates are essentially the same. The only difference you can see in the in the dummy variable that define programs with spillover in other sectors, that instead in both the two dependent variable is now negative. That means that a program with these economies of scopes set lower level of energy saving and renewable production. And the main difference we can find is in the effects of the cluster variable representing the different structures of emissions, because here cities with balance emissions between residential and transport sectors, here as they have a negative side. They are negative correlated with the climate expected targets, while the cluster 2 has no significance. And same things, now let me show you for the production, renewable production. And now can we go straight forward to the, to the conclusion? What we can say, first of all, that urban climate mitigation program, urban climate tech solution need to take into account when they design the best urban mitigation strategy, city factors such as the urban sprawl rate and the density, because this variable significantly affect the expected climate outcomes. And we see also that the structure of the carbon emission in terms of emission sources is significant in affecting the expected climate outcome. And the last thing we have to say that is that cities where the main source of emission is the residential sector tend to increase their expected climate outcomes in terms of energy saving and renewable production, while city where the main sources of emission is the industry sector, the group of city belonging to the cluster 2, tend to increase the climate targets in terms of emission, black carbon emission reduction. Now, this presentation is concluded. Thank you for your attention.
Okay, thank you. Hi, ladies and gentlemen. Thank you for making efforts to today. It's my honor to speak here, and I'm very glad to share my topic with you. Let's introduce myself first. My name is Zhao Jun. I'm a doctoral candidate from University of International Business and Economics. Now, I would like to present my paper, Can Financial Inclusion Facilitate Carbon Neutrality in China, the role of energy efficiency. And my presentation will cover the following 7 aspects. The first part is the introduction. The second is relevant literature. The third part effectively assess China's financial inclusion. The first part constructs the economic model and introduce the variables and data. The fifth part reports the empirical findings. The sixth part further examines the moderating and mediating roles of energy efficiency in the process of China's financial inclusion affecting carbon dioxide emissions. The seventh part summarizes the whole article. Why does the government implement financial inclusion? Finance is an important guarantee and effective means of controlling national social economic development. A sound financial system and highly efficient financial institutions are conducive to promoting sustainable development of an economy and society. At present, supporting for small and medium-sized enterprises is far less than that for large enterprises and state-owned enterprises with abundant capital and broad development prospects. Financial inclusion refers to a condition in which every working person has access to reliable financial services such as credit and insurance from financial services institutions. The nexus between financial inclusion and carbon dioxide emissions mainly including two types, positive effect and the negative effect. The paper's main research contains mainly includes as follows. We first assess China's financial inclusion composite index based on the provincial panel data for the period 2004 and 2018, and then investigate the potential special effects of financial inclusion on carbon dioxide emissions. In addition, the moderating and mediating roles of energy efficiency in the relationship between financial inclusion and carbon dioxide emissions are also discussed. There are 3 contributions, mainly including special effects, moderating effects, and mediation effects. The literature review mainly includes 2 aspects. One is the financial inclusion and carbon dioxide next, and another is energy efficiency and carbon dioxide next. This is the educator system of my paper. Mainly evaluates financial inclusion in China. The left is the time trend chart. We can see that the development of China's inclusive finance shows a fluctuating upward trend, reaching the optimum in 2011 in sample period from 2013 to 2018. The annual average financial inclusion index exhibits a slight upward trend. The left chart is the special distribution of financial inclusion. We can see that significant regional heterogeneity exists. The development of inclusive finance in the Eastern coastal areas of China is significantly better than that in the central and western regions. This is the model construction. We select the special economic models to investigate the relationship between financial inclusion and carbon dioxide emissions. This indicator represents per capita carbon dioxide emissions. Fi refers to financial inclusion, and E indicates energy efficiency. PGDP denotes economic growth. ISU represents industrial structure operating. URB refers urbanization level. This is the 5 models. This is the multi-weighted framework. And the second is the benchmark regression model. There are 3 special models, mainly including SAR, SEM, and SDM. This is the variables measurement and the descriptive statistics. We reported the definitions, observations, means, and the minimum and the maximum of the select variables. The data mainly obtained from China emission accounts and the data sets, China Energy Statistical Yearbook and China Statistical Yearbook. This is the 5 part is the mathematical and the empirical findings. We first construct the benchmark special weight mainly select the geographic distance metric impressed by the ratio of the square of the superior distance between the 2 variables. It is calculated by the equations, where R indicates the radius of the Earth, X and Y refers to the latitude and longitude of each percent of capital city. And then we conduct global special auto collection checks, mainly including Moreland's index and JERS C index. They are calculated in the two following volume respectively. This is the test results of the Moreland's index and the JERS index, which is in the tables. The stacked of the Moreland's index and JERS stacks are significantly higher and lower than 0 and 1 respectively. This suggests a significant spatial auto collection of carbon dioxide emissions under the geographic distance matrix. In other words, places with higher per capita carbon dioxide emissions tend to be adjacent to province with the same carbon emission characters and vice versa. This is the chart of the Moreland scatter plot in select years in the 4 years. We can find that a significant agglomeration effect exists between provinces. More significantly, most places are concentrated in the first and third quadrant. In other words, a majority of premises present mainly high and low agglomeration. We also reported the local indicators of spatial association map in select years, in 4 years here. We can find that the heterogeneous effect of the spatial agglomeration of per capita carbon dioxide is significant. The provinces in southern China mainly show mainly low agglomeration, while the northern provinces exhibit high and high hydrogen emissions. This shows that per capita carbon dioxide in northern China are significantly higher than those in the southern China. Then we present the test results of the model selection, which mainly includes 4 steps, and we finally select the special area model to conduct the empirical analysis. This is the estimated results of the special effect of the SEM model. From a macro perspective, the overall development of China's inclusion finance can significantly provide sufficient capital to stimulate economic growth. From the macro perspective, the focus of China's inclusive finance is a small macro enterprise and the urban low income group. Sufficient basic capital can make residents to start a business and obtain employment, which has significantly improved the residents' purchasing ability of big-ticket items. Also, we conduct the further discussion on the moderating effect analysis. The left table is the estimated results of the moderating effect analysis. We can find that the sufficient of the interaction term is significantly negative is here. When introducing the interactive term of financial inclusion and energy efficiency, the coefficients of financial inclusion drops significantly, while the absolute value of energy efficiency obviously rise. And then we conduct the mediation effective analysis. This is the model. This is the models, and the left table is the results, estimated results. This is the last part is the conclusions and the policy implications. The main conclusion mainly includes four aspects. The first is the development of China's inclusion finance presents a slow and fluctuating upward trend. China's financial inclusion is positively associated with per capita carbon dioxide emissions. In other words, inclusive finance development currently can effectively mitigate the greenhouse effect and contribute to carbon neutrality. The moderating role of energy efficiency can effectively reduce the promotion effects of financial inclusion on carbon dioxide emissions and significantly enhance the carbon emission reduction effects of improved energy efficiency. The first is China's financial inclusion not only promotes carbon dioxide emissions directly, but can also exacerbate the green effects by impacting the improvement of energy efficiency. There are 4 policy implications, mainly from government supervision, market regulation, and clean energy and green technology. Thank you for your listening. That's all. Thank you.
providing the opportunity to present our paper in this well-renowned conference. The topic of our presentation is, our paper is, how does inclusive innovation play a role in sustainable economic growth? My co-authors are Professor Zaid from EDC Para Business School, Muhammad Azam from University of Lahore, Pakistan, myself, Dr. Ahmed Imran, Associate Professor in Ghazi University, Professor Beirloj, he is Professor in ESCO School, and Muhammad Abdul Aziz, he is from University of Portsmouth, UK. So I start from the introduction of our paper. Innovation is important for sustainable development. The innovative production process are critical for a higher living standard and sustainable development goals. This innovative transmission helps to improve products that can contribute to improving their environmental efficiency. Remains a major concern, which is a major concern in today's era of specific to sustainable development goals. However, the process of innovative products is slow in developing countries as compared to the developed ones. So, considering the relevance of innovation in new sustainable development design, it is crucial to evaluate its significance for sustainable development. However, the financial and economic crisis in form of COVID-19 has made sustainable economic growth objective were tough to achieve. In this context, sustainable technological development is crucial path to stop damaging economies from a social economic perspective. Mortazivi et al. The inclusive innovation adoption phenomena has potential to address the socio-economic exclusion issues in the path of sustainable production and development. There is an essential need to focus on inclusive innovation adoption in the process of sustainable development growth, economic development and growth. What motivated us to work in this domain, in this topic? There are several factors. Inclusive innovation includes the development of new products and services for those who are excluded from the mainstream of economic development, especially living in limited incomes, having the limited income group. As Higgs et al. Suggested that inclusive innovation includes the people in the mainstream. Therefore, inclusive innovation adoption is considered an important element to cope with the socio-economic issues in different parts of the world. Furthermore, sustainable economic convergences are very important to test out the sustainable economic growth pattern. Innovation plays a key role in process of sustainable economic growth. These are some arguments, these are some claims by the literature, and it also helps to reduce economic inequalities, benefit more than the poor. In recent scenarios, inclusive innovation are important determinants of balanced sustainable growth. Human capital is also a vital element for inclusive innovation to occur through formal education and renew its capabilities. So the idea of inclusive innovation adoption is taking importance in the present period to bring excluded group from the mainstream of economic development. It is imperative to improve environmental standards. The governments of the developing countries should focus on inclusive innovation strategies in production and consumption technological development for sustainable future for the upcoming generation. The objective of our paper is to evaluate the heterogeneous role of inclusive innovation in the sustainable economic development. And here are the key insights from literature, different findings different directions are presented of the literature in this slide. First path, here we are talking about different paths. First path, inclusive innovation and sustainable economic growth. It's explored by different scholars, and we developed our hypothesis based on the theoretical foundations and empirical findings of the literature. Inclusive innovation matters for sustainable economic growth. Inclusive innovation has significant impact on sustainable economic growth convergence. The second path, we are going to test the H2, that is inclusive innovation and sustainable economic growth convergence or either divergence. So we construct a second hypothesis, and hypothesis 3 is capital formation and sustainable economic growth. There has a significant impact of capital formation on sustainable economic growth. Further, we have different variables which are used to construct the index of financial inclusive innovation, as well as some control variables which are used in our model. So the methodology, if we look at the methodology, the nature of data is secondary. We use the time series data, panel time series data. Then we extracted the data from WDI, World Development Indicator, and the time span of our study is 2000 to 2019. The sample size of present paper is 70 developing countries. We applied descriptive statistics, normal diagnostic test, which are explained through Shapiro-Wilk, and Shapiro-Francisca test. Then we applied panel quanta aggregation and OLS. So we used the software Stata and Mendeley. Stata is used for hypothesis testing or analysis, and Mendeley is used for reference handling. Here is the description of our variables. The environmental quality, we used the adjusted net saving. It includes the particular emission damage percentage of Gini, and it's been already used in the literature. Then we applies capital formation, output per worker, and gross capital formation as a percentage of GDP, and the worker output per capita. And this data is the data of these two variable is taken from, extracted from Penwald table. Then we constructed the inclusive innovation index. So in this index, we utilized 5 proxies which are used to construct the index, which are employment rate, primary school environment, Gini index, then use of information technology, ICT, and financing for SMEs. And here are the formulas, and the data was taken from World Development Indicator website. So employment in industry percentage of total employment, employment rate is calculated. Then we measure the rest of variables through the proxies which are used in the literature, widely used in the literature, and our measures are supported by different scholars from the literature. Here is the overall picture of our index, inclusive innovation index. For inclusive innovation index, we followed the methodology of McKinley 2010. First, we choose the indicators, dimensions, then set the target weights. Here, equal weights are assigned to each indicator to perform uniform analysis, because one country is good in one parameter and second can be good in other parameters. So One country has strength in one indicator and another country has strength in another indicator. We followed the approach of Jha et al. 2018. Figure 1 indicates there is a decreasing trend in inclusive innovation with the passage of time. If we look at the graph, it states that it's decreasing. So that's why we select this area. It should be inclusive innovation should be promoted in developing countries. So model specification to test the sustainable economic growth convergence, we imply beta convergence method, which is used to assess the speed of convergence or divergence in developing countries towards developed one. In the study, we test absolute B convergence hypothesis, not for the economic growth like Pratt studies has done, but we use the genuine economic savings per capita, as this is the most important part of our paper for better environment quality in the developing countries. We use the following equation to test the model. The econometric model for sustainable economic growth convergence is presented in equation 1. And here ENS is the model 1, denotes the adjusted net saving per capita for specific country I and for time t, and mu t are presenting the random distribution terms. Furthermore, we also developed economic model for evaluation of conditional B convergence for the sustainable development indicator of developing countries, as shown in equation 2. If beta naught value is significant negative, then sustainable development indicators possess a conditional B convergence across the sample. Here are the results of descriptive statistics which we used, and I will I'll move forward to discuss the main results due to limited time. So here we have applied the normality of data diagnostic test. The values of Shapiro-Wick and Shapiro-Fonseca states that data is not normal, then we can go for the B convergence and so on. Quantile regression. Here we distributed our sample into full sample, lower middle income countries, and low income countries. So the first column represents the results of OLS, and the second column, next column to last column, here we utilize the percentiles, 10 percentile, then 20 up to 90 percentile. If we look at the results, which states that there are significant impact of inclusive innovation on sustainable development. So there is convergence is existing in our analysis, and we prove our hypothesis in the overall sample. If we look at the lower middle income countries and low income countries, the results are aligned with the overall sample, but their coefficients are a little bit different, and we can make a decision that we can prove our hypothesis. Yes, there is a convergence between the inclusive innovation and sustainable development. Here we check the conditional convergence analysis of sustainable economic development. Same approach is used, as I stated that we distributed our sample into three main components: full sample, lower middle income, and middle income countries. Here are the results of full sample. If we look at the coefficient of percentile OLS and percentile quantile regression, so states that with the different quantiles, our results are significant, which proves that conditional convergence is there and beta coefficients are negative, and which states yes, there is a convergence between the inclusive innovation and sustainable development. Here we show the results of our subsample, which is lower middle income companies sample, income countries sample, and results are aligned with the overall sample, and we can make our decision. Here we included our rest of the variables, control variables, and we can check the we can test our hypothesis, and our hypotheses are proved based on these results. Same results we found the low income countries, and there is convergence between the inclusive innovation and sustainable development. So here we conclude our study, the significance of technological innovation and Industry 4.0 as an important subject in the context of sustainable development. In this context, innovation and development of new products, either in form of durable or non-durable, have received tremendous attention in the scientific community, and we found that our results, there is significant impact of inclusive innovation on sustainable development in the selected countries for a specific time period. The social scientists are trying to figure out new questions like, does innovation can be done through practitioner participatory approach which benefits the poor segments of the society, and this study is an attempt to quantify inclusive innovation and highlights its empirical importance of sustainable product development, which may lead such towards the sustainable development goals to achieve SDGs. Based on our study, we suggest that the inclusive innovation, communication sector, industry sector, education sector, and marginalized segment in the process of new products development and design is slow due to the fact of weak structural system of developing economies. It should be improved through structural changes, through active involvement in the process of sustainable technological production design. However, the empirical outcomes are more for sustainable economic development. Therefore, inclusive innovation policy should be the main focus despite of individual innovation efforts. In this way, the low income and lower income countries, economies can move towards their steady state convergence pattern in long term. So here are some policy implication. The pattern and design of individual innovation should be with an inclusive innovation approach in developing countries. We observe major flaws that capital savings are investment is more towards the genuine resources or deterring environmental resources. It is serious concern in the selected economies how they should be inclined with the sustainable production and sustainable consumption pattern. The human capital involvement in forms of labor participation in national productivities signals positive outcome and sustainable development. So government's attention in human capital is a potential step towards the sustainable development, sustainable and environmental protection. This research can be extended by capturing the nexus between more environmental indicators and inclusive innovation indicators as well. This is all about our paper. Thank you very much for providing the opportunity to share our findings with the audience. Thank you.
Thank you very much. Hi, everyone. My name is Feng Wang. I'm currently a PhD student at the Chair of Macroeconomy from Leipzig Graduate School of Management. Today, I'm presenting the paper, Carbon Abatement Costs in China, Province Level Sector-Specific Estimates and the Association with Innovation and Social Economic Characteristics. Together, I'm writing this paper with my supervisor, Eric Hiller. The paper is structured as the following. First, we have the introduction, and we address the importance to look at the regional sector-specific level of policy stringency. And the second chapter, we describe the data and the methodology we use. And the third chapter, we present the results and discussion. And last one, we will share the conclusion and the limitations of our research. Global climate challenge is a pressing issue, and China is the largest CO2 emitter in the world. And the policy that China is taking and the commitment China is committing is very, very important. That is why it's very important to look at this issue. China publishes regular basis their 5-year plan, but in this 5-year plan, it only gives you an overall target. And this overall objective is not evenly distributed among those provinces. And within the same province, it is not evenly distributed among the sectors. So it is very important to look at the regional abatement costs and break it down into sector-specific level. And there are two major contributions of this paper. First of all, we took a very novel approach to control for endogeneity in the measurement of marginal abatement costs. And second, we break down the marginal abatement costs into regional sectoral level, which can be used for later research, like productivity, employment, spillover effect research. Shadow price measures the trade-off between desirable and undesirable outputs. The value of desirable output that would be foregone to reduce 1 unit of undesirable output. It is very often called marginal abatement cost. So in the literature, sometimes you see shadow price and sometimes you see the term marginal abatement cost, but the measurement is the same. And there are primarily two efficiency models, namely parametric and non-parametric. They are the most used in this study field. Parametric models use a predefined function form, and the non-parametric model doesn't require a predefined function form. It simply uses the data development analysis approach. This is the theoretical framework. Due to the time limit, I will skip this part. If anybody has any interest, please write me an email. I can share the details later. So this is, yeah. All the data from this paper takes from the statistic yearbook, China Energy Yearbook, Regional Yearbook, Environmental Yearbook, so the published statistic yearbooks. There is no available capital stock statistics in China, so this paper used approach developed by Wu in 2016. Here I would like to take the chance to thank him. He shared his data and his approach, and I took his approach and used the capital stock and the GDP deflator from his approach. All the monetary values are deflated into 2010 constant price, and the deflators are used for all the monetary measurements in this paper. The main variables are the energy consumption, that's the dirty input, employment, that's the clean input, capital stock, clean input, and gross regional output, that's the clean output, and the CO2 emissions are the dirty output. These are the results of the measurement. And this is the results from 2004. As you can see that on the East Coast, the regions have relatively higher marginal abatement costs because they have a lot of industry, especially you see Shandong province, in Shandong province, where you have a lot of polluted industry in that region. And overall, the shadow price gets higher in 2011 and get even higher in 2017. That suggests that the marginal abatement costs in China overall has increased a lot. As a second step, we compare the shadow price to alternative measures of policy stringency. As you can see from this table that it is somehow related to alternative measures, but there is no structured correlation with the alternative measures. Would like to draw your attention to the environmental tax per GDP. As you can see, the correlation coefficient is 0.608. It's positive correlated, so it suggests that the environmental tax can partially explain the policy stringency. However, it can only explain partially. The investment in pollution treatment per industry value added, it's negative. So that means that if the industry receive a lot of investment, the subsidy from the government, that means that the policy stringency is eased to a certain extent. So that is why it's negatively correlated. The association with innovation and socioeconomic characteristics, they are all positive correlated. So that means that the innovation intensity and the shadow price cannot really draw the causal relationship, but they are positive. The more the higher the innovation intensity is, the higher the shadow price is. As the last step, we broke down the shadow price into sector-specific carbon abatement costs. We use the energy intensity, and we interact this energy intensity with the CO2 shadow price of the year. And this is just example. Example is Beijing. And you can see from 2013 until 2017 in different sectors. So we broke down the abatement costs into these are just the primary sectors. Actually, we have over 20 sectors available. And if anybody is interested in to see the original data, I'm happy to share with you. So the conclusion is, despite the estimation techniques used, all the empirical studies get the same tendency. The shadow price of CO2 increased yearly in the past 15 years. And despite the magnitude, the ranking among different provinces are the same. So if you use different models, the magnitude can vary from 200 to 2000, but the ranking stays more or less the same. So the economically developed regions have higher shadow price. And then the shadow price are positively correlated with provincial innovation level in particular, and provinces with the increased energy intensity and the share of the primary sector tend to have a lower shadow prices. And the high energy consumption sectors like manufacturing, production and distribution of electricity, gas and water and transport have higher shadow prices. And this provides a policy indication for different taxation structure on different sectors. There are, of course, a few limitations in the paper. So first of all, different approach give a different magnitude. So it's very difficult to give a fixed tax indication. And The single undesired output estimation is questionable since production usually generates multiple pollutants. So compared to the current tax level in China, despite the regional differences, they are generally too low. And the major approach to reduce pollution and greenhouse gas is through command and control. And this approach is very, very difficult to quantify. And another element is you have an environment policy, and how well the policy are executed. It's very important. In some regions, you can see that the execution is very high. They are very efficient. And in some other regions, and it's not so strict. So this effect is very difficult to measure. That's all of our research. If there are some questions, I'm happy to answer.
Hi, good afternoon, everyone. I'm so happy to bring our study to share with you. I'm Tianle Yang, and from Zhejiang University of Technology of China. And the title of our study is The Impact of Coupling Between Green Finance and Environmental Regulation on Innovation Performance of Unlisted Firms in China. And this study is collaborated with my colleagues, first the PhD candidates, Zhennan Sun from Zhejiang University of Technology of China as well, and Professor Qiang Du from ZJUT, and also Dr. Ming Du from Edinburgh Napier University, UK. And all right, I'll just start with the introduction of the study, why we wanted to do this study. We noticed that there are quite a lot of studies focused on the relationship between the green finance and industry technology innovation performance. And because the green finance, or what we call the financial systems, can introduce the finance or resources into the industries with environmental protection orientation. And it is also found that environmental regulations and enterprises innovation performance are related because there is a direct effect brought by the regulations and policies published by the governments. However, we find that these studies are separated. They ignore a coupling effects between the green finance and the environmental regulations, which may impact firms' innovation activities and performance in a synergy effective way. So our research questions, there are two. First, we wanted to know how the coupling extent between green finance and environmental regulation affect firms' innovation performance. And then, how is this effect moderated by the government's participation? So this is our theoretical framework. So first step, we wanted to examine the direct impacts between the coupling extent between green finance and environmental regulations and firm innovation performance. And second, further, we wanted to test or examine the state ownership background of the firm and how it moderates the mechanism between the coupling extent and the firm innovation performance. And third, we wanted to examine the moderation effects of the regional governance efficiency based on this basic mechanism. So we got three hypotheses altogether. The first one, the direct effects. Hypothesis 1. The coupling extent between green finance and environmental regulation is positively related to the firm innovation performance. And this is the first. As we know, environmental regulations may encourage enterprises to adjust their resource and structure and increase R&D investment to promote technological innovation. This kind of effect could be very direct, particularly in China, in terms of its challenges with the carbon dioxide emission. We noticed that Chinese government has published a series of policies and regulation. For example, they set targets and give quota to these enterprises per year on how much carbon dioxide emissions they could have. So that will lead enterprises directly to improve their technology to satisfy with these specific regulations published by the government. But however, we also noticed that in front of the enterprises, there are actually two different kind of choice. First, they can choose to innovate in accordance with the regulations, but they can also prefer to pay penalties or pay cost if they think that it's not worthwhile to cover the innovation cost. So second point, green finance. The role of green finance may provide support for the green transformation of polluting enterprises and reduce innovation risks while helping enterprises to cross the threshold of technological innovation. So compared with the environmental regulation, green finance is not a pushing power, it's more than like a supporting or inducing power to, what I say, just like a candy to induce enterprises to innovate, to guarantee that they have a series of financial systematic support in long term to some extent. So green finance has effectively improved the actual effect of environmental-related policies, while environmental regulations have also provided necessary policy guidance, or we should say pushing power, to these enterprises. And the coupling and the coordination between the green finance and the environmental regulations altogether or simultaneously optimize the resource allocation of the green technology in the market, and thus it promotes firms to innovate. And hypothesis 2, based on these direct effects, we further wanted to examine the government's participation role. So first, we wanted to examine the firm level, the state ownership structure. We believe that state ownership structure positively moderates the positive relationship between the coupling extent between green finance and the environmental regulations in the firm performance. This is because enterprises with a higher state-owned equity participation may get more support easily from government resources and information policies, and on the other hand, it is more likely for these high equity state-owned structure background enterprises to respond to the government policies, particularly in the context of China, of its special political ideology there, and also the government's power. And then, hypothesis 3, we also believe that the governance efficiency of the government may possibly moderate the positive relationship between the coupling extent between green finance and the environmental regulations on firms' innovation performance. This is also due to the consideration of the execution of these specific policies and the regulations published by the government, and also the financial system regulations by the government. So the regional governance efficiency may improve the standardization and the transparency of market in resource allocation, and thus reduce the negative effects of increasing innovation costs caused by information asymmetry. But if this kind of efficiency is lower, say if the intervenes are much more compared to this information asymmetry, then it bring more negative effects into the market. So that is hypothesis 3. In terms of the examine or test all these 3 hypotheses, here are the data and the methodology. We adopt a panel data involves 1,716 unlisted firms during the period from 2008 to 2017 in China. And here are our main variables. We choose the dependent variables measured by the number of the application of the patents of these unlisted firms. And the main independent variable, the regional coupling between green finance and the environmental regulations. And we also got moderate variables as state ownership background as the structure or equity proportion of the state-owned, and regional governance efficiency is based on the city level data for the cities in China, where the firms registered themselves in, and we also controlled a series of variables with affecting the innovation performance of the firms. And we used a simple multiple regression models. Due to the time limitation, we jump into the main findings here. All the 3 hypotheses are supported. First, the direct effects of the coupling extent of the green finance and environmental regulations. We found significantly positive relativeness between these 2 here, as you can see. And then for the state ownership background, we also find evidences of significant positive relativeness between these 2. And in terms of the regional governance efficiency, the moderation effects, we also find the positive related and the positively moderate the basic mechanism or basic effects of the direct effects. And we conduct a series of robustness checks. For example, we substitute the dependent variables with the number of the authorized application patents. And in terms of the independent variables, we substitute several of the pollutant types in terms of the regulation, environmental regulation measurement. And we also control the year of the policy transition of this country. And all these substitutions leads to a consistent results compared with our raw measurements. And then our main conclusions and contributions. And supported by the empirical evidences, this paper proves that rather than the sole consideration of green finance or environmental regulations, these two mechanisms actually coordinated together to play a crucial role in the innovation process of enterprises. And then this finding also echoes with the previous study in terms of the state background ownership. We found that it actually improves the innovation performance in terms of its moderation role based on this mechanism, because both the green financial systems and the environmental regulations are closely related to the government supporting system and power. And our research further found that the government governance efficiency can also improve the positive impacts of the institution on the enterprise's innovation performance. We also got some limitations which provide the space for the future research. First, we realized that due to the uniqueness of China in terms of its emerging economy status and giant market size and political systems, the conclusions of our study may not apply to other countries or other emerging economies. So we hope that there are more studies extending to other economist research contexts. And due to data availability, our research is mainly based on the sample of all these firms, which are normally big and good firms. Thus, the conclusion may not apply to small, medium-sized, or even micro firms, which are even more sensitive to the regulations, to the policies, and to external institutions. So we call for more future studies on our similar research question. So due to the time limitation, I think I need to stop here. And if you have any further interest on our study, you're so welcome to contact me via my email address, yangtianle@zhut.edu.cn. That's all. Thank you. Bye.
Okay, so hello, I'm Erik Hille from HHL, Leipzig Graduate School of Management in Germany. And today I'm presenting joint work with my colleague Thomas Oelker, who is also from HHL. In our study, we ask ourselves the question, which renewable energy support policies are most effective for international diffusion of renewable energies, and what's the role of innovation? This research is basically embedded in a broader research. In general, environmental policy and innovation are interrelated, obviously, and they are expected to influence the expansion of renewable energy diffusion or renewable energy capacities in multiple ways. On the one hand, over time, environmental policy may induce innovation in renewable energy technologies. This will then most likely reduce the levelized costs of energy, making renewable energies more competitive, and thus indirectly, this then supports the build-up of renewable capacities and renewables diffusion. On the other hand, once renewable energy equipment manufacturers have sufficient technological know-how, environmental policy may also directly influence the renewable energy diffusion. Thus, we are on the third arrow here, and this may actually also work even if there is not a large equipment manufacturer in the country present, but through international projects and exports. How would we like to contribute to this line of research? We would like to contribute in three different ways. On the one hand, we collected a unique database, which is rather broad. We have data on the implementation status of 12 different renewable energy support policies in 189 countries and territories. And this then allows us to actually detail the effect of different renewable energy support policies. Very often studies, they look at aggregates of those policies. Yeah, so at policy clusters, for instance, what's the effect of fiscal incentives? We actually have 6 different fiscal incentives, and this allows us to detail the policy instruments effects. And yes, as you will see later on, this is important. If you just look at the aggregate, this may lead to misleading estimates. And like I said, we look at a very large sample of countries, almost all countries in the world, actually, and almost all countries which joined the Paris Agreement. And this is also important because we can then differentiate between the effects depending on the country's level of development. Then second, we not only look at the effect of the policy instruments implementation, but also at renewable energy technological change. Actually, those two variables tend to be interrelated. Nonetheless, very often studies have not considered this at all. And we actually find in our study that innovation is among the most important drivers of renewable energy diffusion. In particular, induced innovation, hence driven through the implementation of renewable energy support policies. Last but not least, not only innovation and the implementation of renewable energy support policies are expected to influence renewables diffusion, but also the reverse may be the case. Hence, there is some inherent simultaneity. Nonetheless, most studies, in particular the ones that consider international data, like we do, they do not take this into account. And we actually find that if you do not take it into account, again, then the estimates of the policy effects may be misleading. So how does our main model look like? Our main dependent variable are per capita wind and solar capacities installed. We look at both wind and solar capacity jointly, as well as the individual technologies. The most important explanatory variables are policy and innovation. Policy is a vector of the implementation status of the 12 different policy instruments. And like I said, very often studies only look at aggregates of those policies. Hence, we also compare the individual effects to the cluster effects. Second important group of variables or of explanatory variables is our innovation variable. We measure innovation using the current approaches. Hence, we look at domestic knowledge stocks based on patent data. Particularly in the main empirical model, we look at high-value patents. Hence, we size weight the patent families, and we only consider patents which were filed in at least 2 countries. And we actually relieve this in several of the robustness checks. So if you're interested in this, I'm happy to share the paper with you. Obviously, we include also a vector of control variables. And like I said, the explanatory variables are most likely inherently simultaneous. Therefore, we estimate the model using system GMM, and as instrumental variables, we use the lag levels and lag differences of the policy variables and of innovation. Moreover, we lag all the explanatory variables by 1 period in the main empirical model because it's expected to take some time. If you think about construction, well, this may be fairly quick in a country like China, but if you think about other countries, before construction, you have to apply, you need to talk to the authorities, they need to allow you to build it there. So it's very much likely that it will take some time from the actual implementation of the policy until the final construction of new capacities. We also look at longer lag structures in the robustness checks. Now, the interesting part is probably our policy instruments. We have data on 12 different policies, ranging from just plain renewable targets and strategies to the implementation state of feed-in tariffs, where we consider the classic feed-in tariffs like fixed rate and premium feed-in tariffs, as well as the more advanced ones, namely tendering and net metering. We look at quotas, both with and without certificate trading. Hence, in the literature, those are usually called renewable portfolio standards and tradable certificates. And like I said, we look at 6 different fiscal incentives. And those fiscal incentives, they are fairly broad in the sense of the mechanism through which they incentivize the buildup of capacities. So if you think about investment tax credits and capital subsidies, they incentivize fairly early onwards. Yeah, so already when the plant is constructed and starts operations, this is usually granted, which makes them rather easy to project as an investor. Contrary to that, sales-related tax reductions and production payments, they only come into effect once the power plant is producing, it's an operation. And obviously, wind power and also solar power, they depend on the weather, they depend on possible changes later on in the regulation, which makes sales-related tax reductions and production payments maybe a little bit less easy to project for investors. And last but not least, we look at public investments and public procurement. Where did we get the data from? We actually collected the data from various sources. Let's just talk about the most important variables. So the energy measures, at least the base variables, were obtained from the US Energy Information Administration. The policy instruments are based on the global status reports of ENSCON'21. Now, some studies have already used those. We do not use the the information from the global status reports directly. The reason is that they are frequently updated. Sometimes REN'21 in a year later finds out, oh, there has been some change, and then they change it in the next status reports, but obviously they can't change it in an already published file. Therefore, we obtained the updated implementation status of the policies directly from REN'21, and we cross-checked them with various sources such as IRENA, Measures and Policy Database, and also the websites of the authorities. Last but not least, where we get the innovation, the patent data from, it's obtained from the European Patent Office, particularly from PATSTAT. And important is that we do not use the IP classification, but the CP classification, which was specifically developed for cases like ours. The CPC classification actually groups patents which are related to climate change. And it allows you to get a really good estimate of the number of patent families. Now, before I look at the results, let's look at some descriptives. And in the next two charts, I basically grouped the 189 countries into two groups. The first group is shown here. These are the 25 richest countries, richest in the sense that 25% countries with the highest GDP per capita. And on the next slide, you see the main variables for the 75% lowest income countries in our example. What do we see? Well, over the time period, the aggregate capacities, they steadily increased. What could be reasons for that? Well, you see that innovation during the same time period also strongly increased. So knowledge stocks strongly increased. However, they peaked around 2016, which can be explained by the fact that innovation activity in terms of patenting actually peaked in 2011, 2012. And this is an indication that those technologies have become more mature. It's become more difficult to add additional knowledge that's worthwhile patenting. During the same time period, we see that those different clusters of policies have been implemented fairly highly already at the starting years. So in the starting year, those policies are actually lagged by 1 year. So in 2004, the implementation rate ranged between 35% for quotas up to 70% for targets. And they then increased slightly until 2017. How does the picture look like for lower income countries? Well, you can see it looks fairly different. What looks kind of similar is that aggregate capacities strongly increased. However, here we have more of an exponential growth, and this growth is strongly influenced by new capacities in China. Overall, capacity additions in 2018 in lower income countries were roughly the same as in the 25% richest income countries. However, what is fairly different is the knowledge stock of innovation. So it's much lower. At the same time, however, the implementation rate of feed-in tariffs and quotas strongly increased. So here, when we look at the percentage of countries which implemented, for instance, targets, it's pretty much the same. Roughly 85 to 90% of countries in lower income countries implemented targets, and also similarly, we can find similar shares with regards to fiscal incentives and feed-in tariffs. Only for quotas, the percentage of countries that implemented quotas is lower. Now let's look at some examples of results. Here are the base results. What we did are two things. On the one hand, we looked at both solar and wind capacity together. And in the next slides, we then specified the technology-specific effects. When it comes to each of the estimations, we started out in the base estimations by including only the clustered variables. Yeah, so only the groups of policies. And then step by step, we detailed the effects. Yeah, so in this third, for instance, in the third column, we detail the effect of feed-in tariffs, so on and so forth, until in the last column, we then only include the detailed policy instruments. Now, I only show you shares or parts of the estimations. The detailed estimations can be found in the paper. What do we find? We find that, of course, innovation is very important. It's one of the most important drivers of capacity additions. And when it comes to policy instruments, the most effective policy instruments are tendering, so a more advanced feed-in tariff, tradable certificates, and investment tax credits. On the contrary, targets and sales tax reductions, which are actually the policy instruments that have been implemented most frequently in the countries, are least effective. Yeah, and the idea is that both targets and sales tax reductions, they are less tangible and projectable. Yeah, of course, targets by their mere implementation, they should not change anything. And we'll see actually when we look at the long run effects, this is also the case. What else is interesting? Well, one can also compare the clustered effects to the individual policy instruments effects. And this is particularly interesting when looking at fiscal incentives, where the aggregate effects actually negative. However, when you detail the individual policy instruments, we find both positive and negative influences. In other words, if you do not detail the policy effects, then one might get the idea that fiscal incentives are not very effective. However, when you detail it, you see that some of the fiscal incentives are highly effective, whereas others aren't. Hence, it's really important to detail the policy effects. Last but not least, obviously, countries do not just implement one policy at a time. On average, policies that implemented a policy actually implemented 4 different policies at a time. Now, as we find that several policies are positive, have a positive influence at the same time, it's an indication that it makes sense to have a mix of support policies. Now, does the effect look different with regards to specific technologies? No, it's pretty much the same. Actually, there's just one additional policy instrument that becomes effective. And these are capital subsidies. We find this both for wind and solar. So there are slight differences, but overall, the technology-specific influences of the policies are fairly similar. Yeah? So what matters are usually tangible, projectable influence, or we're looking for tangible and projectable fiscal incentives on the one hand. On the other hand, tendering and tradable certificates are the most effective feed-in tariffs and quotas. Last but not least, let's look at some of the robustness checks which we did, because they also provide additional ideas. First, contrary to much of the literature, for example, Pop et al. Paper in Energy Economics, and also Verdolini et al. 2017 Energy Policy Paper, they do not find a strong influence of innovation. Instead, they say, okay, there is usually a more important role of environmental policy. Now, therefore, we basically checked what could be a reason for that. Yeah? And remember the second slide I showed you, we said that first, obviously, innovations need to be induced or can be induced, and this then may help to increase the installations. Hence, in the first column here, we check for induced innovation effects through the implementation of policy instruments by interacting the direct clusters of the policies with the innovation variable. And what happens then is that the direct effect of innovation becomes insignificant. In other words, innovation or the effect of innovation on the addition of renewable energy capacities appears to be largely induced through the implementation of policies. Particularly for our sample, this seems to be quotas. Why quotas? We'll talk about this actually when it comes down to our composition of the sample. We include a large share of lower income countries. Then the second interesting thing is the control for endogeneity. We said that many studies do not do this, in particular the ones that look at international data. What happens when we do not control for simultaneity is actually shown in column 40. What we see is that the policy effects, the estimated policy effects, partly change. So beforehand, targets were highly ineffective. Now they become strongly effective, which is, I guess, very contrary to what you would expect. The targets simply that the country says, okay, in 20 years, I may want to have a certain share of renewables in my energy mix. But the target by itself is not yet a policy that incentivizes anything. And at the same time, the effects of the other classes become smaller. In other words, if you do not control for simultaneity, but just for omitted variable bias, in this case with a fixed effects estimator, results can change, and also policy advice may be misleading. Here, in those estimations from 30 to 32, you actually see that when you look at longer leg structures, the priorly significant effect of targets becomes insignificant. So just what you would expect. Last but not least, we differentiated the effects, or we calculated the distinct effects depending on the country's level of development. And we find two interesting things. On the one hand, the effect of innovation becomes smaller for lower income countries, which is, I guess, very intuitive because most of the high value innovation has been carried out in the richest countries. On the other hand, we find that quotas tend to be most effective in poorer countries, contrary to richer countries where fiscal incentives are effective. Now, this information seems to hint at the importance of strong institutions. There is basically some line of research which says that the effectiveness of policy instruments depends on the level of development, and the reason is that institutions are less strongly developed in lower income countries, and as a result, market-based policy instruments become less effective in those countries. And our results sort of seem to be an indication that this is also the case for our sample. Last but not least, we find in the poorest countries that there's a strong effect of targets, a strong negative effect of targets. Now, I just said beforehand that obviously in the long run, this is not the case, but why do we find a strong negative effect of targets in the short run? The reason is that, in particular in lower income countries, they implement a target in, let's say, year 0. And then one would expect that they then include or implement from time to time new policy instruments that in the end then drive the buildup of capacities. However, in roughly 1/4 of the countries, this is not the case. So within 3 or 5 years after the implementation of the targets, nothing happens. And that can then be a reason why targets are fairly ineffective in this case. So last but not least, let me sum up our results. We find that induced innovation is very important. Most effective instruments are quotas with certificate trading, tendering, and fiscal incentives that provide very specific investment supports. In contrast, the least effective instruments are the ones which are less tangible and projectable. And last but not least, we find that it's really important to look at the effects depending on the level of development of the country, depending or to control for simultaneity, and last but not least, to detail the policy instruments. So not just to look at the clustered policies, but actually to have a very specific sample that details which particular instruments have been implemented. In case you have any questions, feel free to contact us. I'm happy to share our paper and also to discuss thoughts with you. Thank you very much, and have a nice remaining conference.
sayın hocalarım, değerli meslektaşlarım ve katılımcılar. Bugün sayın hocalarım Doçent Doktor Yasemin Dumrul ile sayın Doçent Doktor Zerrin Kılıçarslan ile yapmış bulunduğumuz çalışmamız üzerinde size bilgilendireceğim. Dear participants, welcome to the symposium. My name is Selma Büyükkantarcı Tolgay. I work as an assistant professor in Kayseri University, Vocational School of the Technological Sciences, Marketing and Foreign Trade Program. We did our study with Associate Professor Yasemin Dumrul and Associate Professor Zerrin Kılıçarslan, which work in the same university. I will make my presentation in Turkish, but in the last part, I will give a brief summary of our study in English. Sunumumuzun ismi Yenilenebilir Enerji ve Teknolojik İnovasyonun Çevresel Bozulmaya Etkisi, RALS Birim Kök ve Rals-Engel-Granger Eşbütünleşme Yaklaşımı. Çalışmamızın amacına değinmek istiyorum öncelikle. Sürdürülebilir kalkınma için yenilenebilir enerjinin kullanımına, çevre dostu inovatif teknolojilere ve bu teknolojileri ortaya çıkartacak Ar-Ge faaliyetlerine ihtiyaç olduğunu birçok çalışmada görmekteyiz. Yenilenemeyen enerjilere alternatif olarak yenilenebilir enerjilerin keşfedilmesi ve tasarlanması, fosil yakıtlı enerjiye olan bağımlılığın ve ekolojik ayak izinin azalmasını da sağlayacaktır. Ayrıca teknolojik yenilik, endüstriyel dönüşüm ve yenilenebilir enerjinin geliştirilmesi yoluyla sürdürülebilir kalkınma, ekonomik ve sosyal kalkınmanın sağlanmasına da yardımcı olacaktır. Belirtilen bu bağlamlarda biz çalışmamızda yenilenebilir enerji ile teknolojik inovasyonun Amerika Birleşik Devletleri'ndeki ekolojik ayak izi üzerindeki etkisinin incelemeyi amaç edinmiş bulunmaktayız. Çalışmamızın önemine bakacak olursak kişi başına düşen ekolojik ayak izi sıralamasında ilk 10 ülke arasında yer alan Amerika Birleşik Devletleri'nin ekolojik açığı -1416.05 kişi başına düşen ekolojik ayak izi 8.22 hektar ve biyokapasitesi ise 3.76 hektardır. Dolayısıyla Amerika Birleşik Devletleri'nde ekolojik ayak izi üzerinde yenilenebilir enerjinin ve teknolojik inovasyonun etkisinin test edilmesi çevresel sürdürülebilirlik açısından da önemli bir rol oynayacağı düşünülmektedir. Çalışmamız 4 aşamada gerçekleştiriyoruz. Birinci aşamada teorik çerçeve, ikincisi uygulamalı literatür, üçüncüsü veri ve metodoloji, ekonometrik analiz ve sonuçlarıyla çalışmamızı tamamlayacağız. Teorik çerçeveye öncelikle bakacağız. Sürdürülebilirliği sağlamak ve çevresel bozulmanın önüne geçebilmenin yollarından biri enerji kullanımını yenilenemeyen enerji kaynaklarından yenilenebilir enerji kaynaklarına yönlendirilmesidir. Diğeri ise enerjinin çevre kalitesi üzerindeki olumsuz etkisini minimize edebilmek için üretim aşamasında enerji kaynaklarının marjinal tüketimini azaltmaktır. Bu bağlamda hem yenilenebilir enerjilerin kullanımı hem de sera gazı salınımına neden olan faaliyetlerin durdurulması, minimuma indirilmesi ya da karbonsuz olanlarla değiştirilmesine neden olabilecek ve enerji verimliliğini sağlayacak teknolojilerin üretim ve kullanımı yaygınlaştırılması bütün dünya ülkeleri tarafından önem arz etmektedir. Teorik çerçevemize devam ediyoruz. Yenilenemeyen enerjinin yaygın kullanımı daha fazla karbon yoğun olduğundan dolayı ülkeler sürdürülebilir kalkınma ihtiyacını göz önünde bulundurarak temiz ve yenilenebilir enerji kaynaklarına yönelmeye başlamışlardır. Yenilenemeyen enerji kullanımı ithalata bağımlılık, fiyat dalgalanmaları, maliyet verimsizliği ve ekolojik dengesizlik gibi olumsuzluklara yol açtığı da görülmektedir. Yenilenebilir enerji fosil yakıt bağımlılığını azaltarak hava kirliliğini önleyebilir, sera gazı emisyonlarını azaltabilir ve enerji güvenliğini sağlayabilir. Yenilenebilir kaynakların kullanımı enerji maliyetlerinin, fosil yakıtların çevre ve iklim üzerindeki olumsuz etkilerinin azaltılmasına, hava kalitesinin ve insan sağlığının iyileştirilmesine, istihdam yaratılmasına yardımcı olacaktır. Ayrıca yerli yenilenebilir enerji kaynaklarının kullanılmasıyla da enerji ithalatı ile ilgili maliyetlerin de azaltılacağını söyleyebiliriz. Sürekli artan enerji talebi nedeniyle yenilenebilir enerjinin geleceğin en önemli enerji kaynağı olduğu ve aynı zamanda çevre dostu bir enerji kaynağı olduğu da bütün dünya ülkelerince yapılan oturumlarda da bilinen bir gerçek olmaktadır. Dolayısıyla bu ülkeler bu nedenle yenilenebilir enerjiye yönelmeye başlamaktadırlar. İnovasyon faktörüne gelecek olursak kaynak verimliliğini artıran Ar-Ge faaliyetlerinin ve yenilenemeyen enerji kaynaklarının daha etkin kullanımını sağlamak ve yenilenebilir enerji kullanımını artırmak için ileri teknolojiler elde etmeyi amaçlayan yeşil yatırımlara odaklanarak ekolojik ayak izini azaltabilmekte ve ekonomik kalkınmayı sağlayabilmektedir. Aynı zamanda inovasyon faaliyetleri sera gazı yayılımını azaltmaya ve enerji tasarrufu sağlamaya, yeni yenilenebilir enerji kaynakları üretmeye ve yenilenebilir enerji kapasitesini artırmaya da yardımcı olabilir. Uluslararası Enerji Ajansı'nın 2018'deki raporuna göre karbon yoğun enerji kaynaklarının kullanımı ve ekonomik büyüme çabaları hem gelişmiş hem de gelişmekte olan ülkelerde ekolojik ayak izi seviyesinin artmasında etkili olmaktadır. Sürdürülebilir kalkınma açısından hem yenilenebilir enerji kaynaklarının kullanımı hem de inovatif faaliyetlerin artması ekolojik ayak izinin azalmasına katkıda bulunacaktır. Ekolojik ayak izi terimi her ne kadar doğaya sahip olduğumuzu ve her ne kadar da kullandığımız ve bu doğayı ne kadar kullandığımızı hesaplayan bir ölçüdür. İnsan faaliyetleri tarafından talep edilen mal ve hizmetlerin üretim süreci de yine ekolojik ayak izi ile ilişki içindedir. Çevre literatürüne göre ekolojik ayak izi yaygın olarak önemli çevresel bozulma ve sürdürülebilirlik göstergesi olarak kullanılmaktadır. Uygulamalı literatürü incelediğimiz zaman çalışmaların bazılarında teknolojik yeniliklerin çevre kirliliğine etkisi negatif iken bazılarında pozitif olduğu tespit edilmektedir ve son zamanlarda da özellikle yenilenemeyen enerji kaynaklarının azalması kaynaklı olarak da birçok bilim adamının teknolojik inovasyon ve çevresel bozulma konularında da çalışmaların yoğunlaştığını görmekteyiz. Ben ilerleyen sunumlarımda İngilizce'de bir sunum yapacağım için literatür taramasını sadece tablo şekillerinde ve tam metinde göstereceğiz. Çok üzerinde değinmeyeceğim ancak kısa olarak şöyle bahsetmek istiyorum. Burada teknolojik yeniliğin çevre kirliliği üzerine bazı çalışmalarda çok etkisinin olmadığı, bazı çalışmalarda da pozitif yönlü bir etkisinin olduğundan bahsedilmektedir. Birçok çalışma bulunmakta. Son zamanlarda da çalışmaların, araştırmalarımıza göre çalışmaların yoğunlaştığını görmekteyiz. Veri ve metodoloji kısmımızda çalışmamızda çevresel bozulma üzerinde yenilenebilir enerji tüketimi ve teknolojik inovasyonun etkisini REALS tekniği kullanarak 1980-2016 döneminde Amerika Birleşik Devletleri ekonomisi için analiz gerçekleştirmiş bulunmaktayız. Im ve Schmidt'in 2008 yılındaki kalıntıların normal dağılmaması halinde kalıntıların yüksek momentlerin kalıntılar hakkında bilgi içereceğini ve bu yüksek momentlerin modele dahil edilmesinin kalıntıların varyansını düşüreceğini ve bu da normal dağılmayan kalıntılardaki bilgileri kullanmayan testlere göre daha güçlü sonuçlar elde edeceği çalışmasından yola çıkmış bulunmaktayız. Bu çalışmada kalıntıların yüksek momentlerinden elde edilen bilgilerin birim kök ve eş bütünleşme testlerine eklenmesinde Im ve Schmidt tarafından geliştirilen REALS yani kalıntılarla genişletilmiş en küçük kareler tekniğinden faydalandık. Veri kaynaklarımıza bakacak olursak çalışmada çevresel bozulma göstergesi olarak burada ekolojik ayak izini ve veri kaynağı da küresel ayak izi ağından elde ettik. Teknolojik inovasyon göstergesi olarak patent kullandık ve Dünya Bankası kalkınma göstergelerinden faydalandık. Ayrıca çevresel bozulma üzerinde hem yenilenebilir hem de yenilenemeyen enerjinin etkisini görebilmek amacıyla her iki enerji tüketim verisinde analize dahil edilmiştir. Bu yenilenebilir enerji tüketimi ve yenilenemeyen enerji tüketimin de veri kaynakları Uluslararası Enerji Ajansı'dır. Aynı zamanda analize dahil etmiş olduğumuz bütün bu değişkenlerin logaritmik dönüşümleri de gerçekleştirilmiştir. Ekonometrik analizimiz 3 aşamadan oluşmakta. Birinci aşamada değişkenlerin doğranlığı test edildi. İkinci aşamada uzun dönemli bir ilişkinin varlığının test edilmesi gerçekleştirildi ve üçüncü aşamada da uzun dönem katsayıların ortaya konularak yorumlanması gerçekleştirildi. Sırasıyla ekonometrik analiz sonuçlarımıza inceleyecek olursak, bu çalışmada ilk olarak ADF birim kök testinden elde edilen kalıntıların normal dağılıma sahip olup olmadığını ortaya koyabilmek amacıyla Jarkoya-Bera testi yapılmıştır. Jarkoya-Bera testi sonuçlarına göre teknolojik inovasyon, yenilenebilir enerji ve yenilenemeyen enerji tüketimi normal dağılıma sahip iken ekolojik ayak izi verisinin %10 anlamlı düzeyde normal dağılıma sahip olmadığı tespit edilmiştir. REALS ADF birim kök testi ve sonuçlarına bakacak olursak, çalışmada öncelikle durağanlık sınaması yapılmasında Im ve diğerleri tarafından geliştirilen ve ADF birim kök testinin kalıntılarının genişletilmiş hali olan RealS-ADF birim kök testi kullanılmıştır. Değişkenler için hesaplanan test istatistikleri asimptotik kritik değerler ile karşılaştırıldığında temel hipotezin reddedilmediği görülmektedir. Buna göre seriler birim kök içermekte ve değişkenler birinci fark alındığında durağan hale gelmektedir. RealS-Engle-Granger eşbütünleşme yaklaşımına baktığımızda ise değişkenlerin durağanlık seviyeleri belirlendikten sonra bir sonraki aşamada değişkenler arasında bir eşbütünleşme ilişkisinin var olup olmadığı Lee ve diğerleri tarafından geliştirilen RealS-Engle-Granger yaklaşımı kullanılarak test edilmiştir. Bu test Engle-Granger testinin gücünü artırabilmek amacıyla Im ve Schmidt tarafından önerilen RealS tekniği Engle-Granger testine uyarlanmıştır. RealS-Engle-Granger eşbütünleşme testinin sonuçlarında ise burada hesaplanan RealS-Engle-Granger test istatistiği kritik değerlerden büyük olduğu için sıfır hipotezinin reddedildiği görülmektedir. Buna göre ele alınan dönemde Amerika Birleşik Devletleri'nde ekolojik ayak izi, yenilenebilir enerji tüketimi, teknolojik inovasyon ve yenilenemeyen enerji tüketimi değişkenleri arasında uzun dönemli bir ilişki tespit edilmiştir. Uzun dönem katsayılarının belirlenmesinde RealS-Engle-Granger eşbütünleşme testi sonrasında Phillips ve Hansen tarafından geliştirilen FMOLS ve Park tarafından geliştirilen CCR yöntemleri kullanılmıştır. FMOLS bağımsız değişkenler ile hata terimleri arasındaki içsellik ve hata terimleri arasındaki otokorelasyon problemini dikkate alan testlerdir. CCR ise geleneksel en küçük kareler yönteminden sapmaları ortadan kaldırılan bir yöntem olarak ifade edilmektedir. Tablodan da görüleceği üzere FMOLS ve CCR yöntemleri kullanılarak elde edilen uzun dönem katsayıları birbirinin oldukça yakın olduğu tespit edilmiştir. Başka bir ifadeyle her iki testin sonucu birbirini desteklemektedir. Elde edilen sonuçlara göre ekolojik ayak izi üzerinde yenilenebilir enerji tüketimi ve teknolojik inovasyon negatif, yenilenemeyen enerji tüketimi ise pozitif bir etkiye sahiptir. Buna göre Amerika Birleşik Devletleri'nin yenilenebilir enerji tüketimindeki ve teknolojik inovasyondaki %1'lik artış ekolojik ayak izini sırasıyla %0.05 ve %0.11 azaltırken yenilenemeyen enerji tüketimindeki artış ekolojik ayak izini yaklaşık olarak %1.09 artırmaktadır. Bununla birlikte elde edilen uzun dönem katsayıları %5 önem düzeyinde istatistiksel olarak anlamlı bulunmuştur. Sonuca değinecek olursak çalışma ABD'de çevresel bozulma, yenilenebilir enerji, inovasyon ve yenilenemeyen enerji tüketimi arasında uzun dönemli bir ilişki olduğunu doğrulamaktadır. Ayrıca çalışmada yenilenemeyen enerji tüketiminin çevresel bozulmayı artırdığı, yenilenebilir enerjinin ve teknolojik inovasyonun ise çevresel bozulmayı azalttığı bulgusuna da ulaşılmıştır. Sera gazı salınımına neden olan faaliyetlerin durdurulması, minimuma indirilmesi veya karbonsuz alanlarla değiştirilmesine neden olabilecek, enerji verimliliği sağlayacak teknolojilerin teşvik edilerek kullanılması, enerji sektörüne yönelik inovatif faaliyetlerin artırılması ve yenilenebilir enerji kaynaklarının geliştirilmesi önem arz etmektedir. Bu bağlamda ekolojik ayak izini azaltmaya yönelik olarak yeşil enerji politikalarının oluşturulması çevresel tahribatla mücadelede politika yapıcılar için kilit rol oynayacaktır. Now, I will present presentation in Turkish. Our topic is the effect of renewable energy and technological innovation on environmental degradation, RALS unit root and RALS Engle-Granger co-integration approach. Purpose of the study. For sustainable development, there is a need for the use of renewable energy, environmentally friendly innovative technologies, and R&D activities that will reveal these technologies. Discovering and designing renewable energies as an alternative to non-renewable energies will reduce dependency on fossil fuel energy and reduce its ecological footprint. It will also help achieve sustainable development, economic and social development through technological innovation, industrial transformation, and the development of renewable energy. In this context, in this study, it's aimed to examine the effect of renewable energy and technological innovation on the ecological footprint in USA. Importance of the study: the ecological deficit of the USA, which is among the top 10 countries in ecological footprint per capita. Capita is minus 1,360.05. Its ecological footprint per capita is 8.22 hectares and its biocapacity is 3.76 hectares. Therefore, testing the impact of renewable energy and technological innovation on the ecological footprint in the USA will play an important role in environmental sustainability. Theoretical framework: one of the ways to ensure its sustainability and prevent environmental degradation is to shift energy use from non-renewable energy sources to renewable energy sources. The other is to reduce the marginal consumption of energy sources during the production phase in order to minimize the negative impact of energy on environmental quality. In this context, it is important to expand the production and use of technologies that will provide energy efficiency, which can cause both the use of renewable energies and the activities that cause greenhouse gas emission to be stopped, minimized, or replaced with carbon-free ones. Data and methodology: in the study, the effect of renewable energy consumptions and technological innovation on environmental degradation was analyzed for the US economy in the 1980 to 2060 period using the RAL's residual augmented least squares technique. In this study, RALC techniques developed by Im and Schmidt was used to add the information obtained from the high moments of the results to the unit root and co-integration tests. In the study, first of all, RALC and ADF unit root test, which is an extended version of ADF unit root test with residues and developed by Im et al. The existence of the co-integration relationship between the variables was tested using the Rals-Engel-Granger approach, which is an adaptation of the RALC technique to the Engel-Granger test and developed by the Lee et al. 2015. FMOLC and CCR techniques were used for long-term coefficient estimation. Conclusions: this study confirms that there is a long-run relationship between environmental degradation, renewable energy, innovation, and non-renewable energy consumption in the USA. In addition, it has been found that non-renewable energy consumption increases environmental degradation, while renewable energy and technological innovation reduce environmental degradation. It is important to encourage and use technologies that will provide energy efficiency, which can cause the activities that cause greenhouse gas emission to be stopped, minimized, or replaced with carbon-free ones, to increase innovative activities in the energy sector and develop renewable energy sources. In this context, the creation of green energy policies to reduce the ecological footprint will play a key role in the fight against environmental degradation. Thanks for attention. Dinlediğiniz için teşekkür ediyoruz.